This problem is example 2 on page 176. And just to refresh you of what it says gasoline, and I have a typo there, so let me change it. Gasoline consumption in the U.S. has been increasing steadily. Consumption data from 1992 to 2004 is shown. Find a model for this data and use it to predict consumption in 2016. If the trend continues, when will consumption reach 200 billion gallons? Okay, so we've got a few things that we need to do. And normally we would solve this problem using algebra. We're not going to have to do that though. We're going to look at this and we need to make some predictions. And, you know, again, we've got these years here, but notice how the numbers kind of flow. When I type in 00, I get 0, 1, 2, 3, 4 down here. So your data looks funny, and you know that 1992 came before 2004, so it's going to be better and make your data flow better if you start with 1992 as 0. So I'm just going to go straight down the page and type my numbers in there. Okay, so we have 12 years of data here, and just to remind myself of what I'm looking for, it says find a model for this data and use it to predict consumption in 2016. So we are trying to find a number for the year 2016. And if I were going to do that, I would have to go all the way down here to 2016. So I would need to figure out what number 2016 was. So if this starts with 5 and this starts with 13. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is 22 more numbers. So 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we would be at year 24 if we did that. So we would need to look at number 24. So, and let's check our math and make sure. Let's just check those again just to make sure. Year 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is 22 more years. So 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So, yeah, number 24 is what we're looking at. So, if we take a look at this, and we start with 92 and we call 92 year 0. And you know, you could call 92 year 1 if you wanted to. But most of the time we're going to call our starting one 0. So what we're going to do is we are going to highlight our data. And this is how you make a model. Okay. So I'm going to highlight. My cursor got stuck. So let's see. Highlight my data. Insert chart. And remember, for these, we are looking for scatter plot. I'm going to move this over a little bit so I can see it a little bit better. But that's not a scatter plot. I'm going to use the old chart editor to make things look consistent. I'm going to go over to chart types. I'm going to go down to scatter plot. And notice over here, it's not exactly a straight line, but it's close enough. It's very, very close to a linear model. It's just sometimes your data doesn't, you know, this is life, so it's not always a straight line. Now we're going to do customization. I'm going to make it pretty. We're going to say gasoline consumption. I'm just going to give it a title. I'm going to go down and let's see. On the horizontal axis, which is this one here at the bottom, these are your years. So years. And these represent, according to your chart, these represent billions of gallons of consumption. So I'm going to say that so that we know that that's in billions. So I'm going to say gallons of consumption in billions. So that everybody knows it was in billions. Okay. So we're going to keep going down. We're going to go down to where our math is. And I'm going to say linear trend line. This is linear data. This is what we're talking about right now. Later on, we'll talk about some of the others, but right now we're talking about linear. So I'm going to hit linear. It has a pretty close straight line. Let's see what it says about the r squared. Remember that r squared will tell us how close it is to being a straight line. The closer this number is to 1, the closer it is to a straight line. That's pretty darn close to 1. I'm going to also tell it that I want an equation so that I can make a prediction. So my equation is 2.18 times x plus 109. So I'm going to hit update, put my nice little chart there. I'll click on it and move it over just a little bit so we can see it a little bit better. And I'm going to go down here and I'm going to say y equals, and I'm just going to remind myself what my equation is in case I'm asked. So there's my equation. So if your instructor asks you what's the prediction equation, that's what you would have. And we, remember, want to make a prediction for the year 2016. So let's see. So 2016, I believe we said that was year 24. So we'll call it year 24 anyway for this prediction. And we'll say equals 2.18 times 24 plus 109. And that's going to give me 161.32. So if I came down here and I said that was year, what do we say, 24? No, 24 is going to go here. We don't want to do that. We want to call this year 16, like we've been doing. And this is 24, and this is 161.32. Let's see if it makes our line straighter now. Yeah, made our line straighter, gave me a prediction way out, but it gave me a different kind of line. Okay, so that's my model. That's my equation. What else does this problem say? This problem also says, let's go back to my notes so I can say it says, if the trend continues, when will consumption reach 200 billions? So what it's really asking is, when will this Y value be 200 billion? So right now, this is our equation. They're asking me for the year. They're saying in what year. So these were our years. This is where we were making predictions before. They're now saying, in what year will that give me 200 billion? So I'm going to go over here to my piece of paper. We'll go down here for a minute. Y equals, what was my equation again? Let's go back to it so I can see it. Y equals 2.18x plus 109. 2.18x plus 109. This one you have to do just a little bit of algebra, but nothing that you can't handle. This one, instead of asking me to make a prediction and plug a number in for x, which were the years, they're saying, what if you knew what the answer was? What if it was already 200 billion and you were trying to find what year that would be? So when you do algebra this way, if you're trying to get an x value by itself, what you do is you subtract this number. So we would subtract 109. So 10 minus 9 is 1. 9 minus 0 is 9. 1 minus 1 is 0. So this would be 91 equals 2.18x. And in order to get the x by itself, you have to divide both sides by 2.18. So this is the only little bit of algebra that you're going to need to do for this one. So I would take my calculator and do 91 divided by 2.18. So let's pull this calculator up. So 91 divided by 2.18. Enter. So roughly year 41.7, so year 42 if I rounded. So if I go back to my data and I look at it, and I say, okay, year 42 is way down here. It is, in order to get to 42, 42 minus my 24 would be how many more years? So 42 minus my 24 would be 18 more years. So 16 plus 18, if this is 2016 and we want to add 18 to it, you know, and I can do some math here. Remember, Google does math. So equals 16 plus 18 would be the year 2034 would give me that answer. So that answers all those questions in that problem without doing, we're just doing a very minuscule amount of algebra here. You can do all these things with Google and not have to worry about remembering all your algebra.